All right, this is question 9 from lesson 3. And what we're looking at, they're giving us 4 points. They want us to determine if vectors A, B, and C, D are parallel. So remember with vectors can be moved anywhere you want. All right, but what they want to know is, does the vector A, B, and vector C, D head in the same direction? So we're not worried about the magnitude. We're just worrying about the vector themselves. So we don't even have to go down to unit vectors. A lot of people will say, well, you got to find the unit vector and compare the unit vector. What I'm going to do is I'm going to show you a quick way to do the check. It saves a step of finding the unit vector. So I'll do question A. So first thing we need to do is find vectors A, B. And vector A, B is point B minus point A. So point B minus point A, so it'll be 3 take away 2 is 1, 6 take away 0 is 6. So there is vector AB. Vector CD then is the point D minus C. So that will be 5 take away 4 is 1. Negative 5 take away 1 is negative 6. And now we make a comparison. What I'm trying to determine is that if AB is a multiple, let's use letter M for argument's sake, is it a multiple of CD? So when I compare them, 1 and 6 equals, can I make the first number the same? Well, it already is, so I don't have to make any changes. So the first X value is the same. However, the Y value is not. So that means it's not pointing in the same direction. It has the same X component. All right, so this one, just for reference here, 1, 6 is pointing in that direction. 1, negative 6 is pointing in that direction. So therefore, not parallel. All right, so therefore, not parallel. All right, try one more, and I'll leave C for you to try on your own to make sure you're good with it. So same process, vector AB is the point B minus A. Works the same way for 3D. So here we have 4 take away 0 is 4. Negative 1. Hopefully I'm doing my mental math properly here. Vector CD equals D minus C. So that one's going to be negative 3. 3 take away 1 is 2. 5 take away 2 is 3. All right, so this one you might be thinking, okay, I can tell right away. If you're not sure, this is what I would recommend. So vector AB is equal to, and what I'm going to do to make the comparison easy, I want a 1 in the X coordinate for argument's sake. So that means I'm going to factor out or divide out a 4, which would leave me with 1, negative 1/4, 1/4. Vector CD, same thing. I want it to be a 1 here. So I want this to be a 1 so it's easy to make the comparison. So I'm going to take out a negative 3, and I would get negative 2/3 and negative 1. So this allows us to make an easy comparison, and we can see the Y components and the Z components don't match up. So therefore, also not parallel. All right. So I'll let you try C, but it's the same process. So when you're checking to see if two vectors are parallel, you're looking to see if they're pointing in the same direction, meaning that their X, Y, Z values are a multiple of each other. So hopefully that clarifies question number 9.